This is my intermediate algebra course. Today we're going to learn how to solve quadratic equations with the quadratic formula. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. As I said, we're going to find a formula that we can use to solve any quadratic equation. And that formula is going to be probably the easiest way to solve most quadratic equations. But before we do that, we're going to pick up where we left off on the last class. We learned how to solve quadratic equations using the completing the square method, but we didn't solve quadratic equations that have complex solutions or equations where this term becomes a fraction and you have to use that fraction to complete the square. So let's get into these problems first, and then when we're done with these, we'll go on to the quadratic formula. So it says here, solve by completing the square. Again, we're just picking up where we left off yesterday, or the previous class. So just like the other problems, to complete the square, we get rid of that coefficient on the x squared term, and we get x squared minus 7/3 x plus 8/3 equals 0. And now, as usual, we're going to put the 8/3 on the other side. And we have to know what number do we add to both sides to complete the square. Now, this is where it gets kind of involved. We have to take this number, and just like we did in the previous classes, we divide by 2 and square it. But now it's a fraction, you see. It's 7/3. So how do we deal with that? And I don't know why I wrote it as a slash. You can write it either way. It doesn't really matter, but I'm just going to keep it like that. So what do we do here? Well, you have to remember what we learned in my arithmetic course. To divide a fraction by 2, you just use the old symbol there. And remember, 2 can be written as 2 over 1. Any whole number can be written as over 1. So remember back to my arithmetic course where we learned how to divide fractions. When you're dividing fractions, you do two things. You switch this sign to multiplication, and then you flip the divisor. So we get negative 7/3 times 1 over 2. And then it just becomes a multiplication problem. And when you multiply fractions, you just multiply straight across. So 7 times 1 is 7, and 3 times 2 is 6. So we get negative 7/6. So that's dividing by 2. Now, I want you to understand, you don't have to show all that. I'm just doing this for your benefit in case you forgot how to divide fractions. Now, if you're rusty on this, that's okay. If you don't recognize this at all, that's probably not okay. That means that you didn't take my arithmetic course or my beginning algebra course or my pre-algebra course. Remember, those are prerequisites for this course. So all that was dividing by 2. But now we have to take that resulting number and we have to square it, just like we did in the previous problems. Remember, take this, divide by 2, and square it. So now squaring is just taking the fraction and multiplying it by itself. And as we just mentioned up here, when you multiply fractions, you just multiply straight across. So we have 7 times 7 is 49, and 6 times 6 is 36, and that's it. Now again, I know that kind of takes a long time to show all that, but it doesn't really take a long time to do all that. You just have to do that, in your head, and it's not really that difficult once you get the hang of it. So I'm going to throw this over to the side, just and keep that there, just so you know what to do there. And I should probably write that negative so it doesn't bleed in there. And so we get 49 over 36. We're going to add that to both sides. That completes the square. And now we have a perfect square. So we can go ahead and factor this because we know it's going to factor to a perfect square. And remember, this number, the number that goes here is always this number divided by 2, and we figured out that is 7/6. Okay, we figured that out here when we divided by 2. So now we just have to add these together, and just like in the previous class, multiply both sides of this fraction by 12, and we get negative 96 over 36 plus 49 over 36. Why did we do that? Well, we had to get a common denominator. And negative 96 plus 49, that's negative 47. And you can change this to power notation just like we did in the previous classes. And, you know, following the same steps that we did in the previous classes, remember to put your plus or minus sign. We're going to get rid of that square. We have to get rid of that square, so we're going to square root both sides. And now we end up with x minus 7 over 6 is equal to plus or minus. And remember, the square root of a over b is equal to square root a over square root b. I know you're probably tired of me telling you that, but that's where that comes from. So we have negative square root negative 47 over square root 36. And so one of the big differences, as I mentioned, is you're dividing this fraction by 2 and squaring it. We didn't have a fraction there, you know, after dividing the coefficient of x squared, so that's different with this problem. But now we come to the second thing that's going to be different about these problems, and that is we have a negative inside the root. Remember, when you have a negative inside that root, the negative just comes out as an I. And the square root of 36, 6 times 6 is 36, so that's just going to be 6. Now, you don't have to show any of the algebra when you take that negative out of the root. You know, you could show negative 1 times 47 and then break it up using this principle. Root a times b is equal to root a times root b. You could show all that. And then the root negative 1 becomes I, and so on and so forth. But again, it's really not necessary to do that. And those rules start to get a little bit weird, and they don't always follow when you're using I, so you know, don't worry about showing the work on that. You can just take all negatives out as an I. So now we have 7/6 plus or minus I root 47 over 6, and we have a common denominator, so we can go ahead and add those together, and the final answer is going to be 7 plus or minus I root 47 over 6. So again, the difference with that problem is that we had we have two complex solutions, and also we had to deal with a fraction here to complete the square. So let's try another one of these problems before you try one on your own. So I'm going to go a little bit faster here just so I don't bore you. So we're going to divide both sides by 5 to get rid of that coefficient of x squared. And as usual, we're going to put the 2/5 on the other side. And then we're ready to complete the square. But we're going to move this work over a little bit to make some room. And we'll put a divider. Don't be afraid to put dividers. They're really useful to help you organize your work. And we're going to take this, divide by 2, and square it. So again, you can do this in your head. I don't want to keep showing those steps. You know, you can look at this and see what to do. You know, dividing by 2 is the same thing as just multiplying by 1/2. You know, so that becomes 4 over 10, and you reduce that, it becomes 2/5. And then you square that, and it becomes 4 over 25. Again, squaring that is just 2/5 times 2/5. So these are all things that you need to start to do quickly. Again, you can refer to the previous problem if you want to, you know, check your work on that. But you know, we can't show that every time, or else it's just going to make this course too long, or this class too long. All right, so now we have a perfect square over here, and we're just going to factor that. And we have x, and remember, this number is always the coefficient of x divided by 2. So we already figured out that's 2/5. Again, you reduced it. You got 4 over 10 when you divided by 2, but you reduced it to 2/5. So don't be confused by that. That's just basic arithmetic. Most teachers would not even stop to tell you about that basic arithmetic. they would not even bother. So I'm trying to, make it as easy as possible for you without boring students who, can do that stuff and remember that stuff. Okay, so now we have negative 6 over 25. We got a common denominator. We'll multiply both sides by 5. Change this to power notation. As usual, you've done these problems many, many times. So now we want to get rid of that square, that exponent there. So we have to square root to get rid of the second power here. And remember, always put plus or minus on the other side of the equation. The other side, the equation opposite the variable. Okay, so now we have plus or minus root negative 6 over root 25 equals x minus 2/5. And remember, the negative in the root can just come out as an I. And you get 5 in the denominator, so on and so forth. And so now we're just going to put the 2/5 on the other side. So we get 2/5 plus or minus I root 6 over 5. And our final answer, if we have enough room, is going to be x is equal to 2 plus or minus I root 6 all over 5. So I'm sorry we ran out of room there. Again, we have a common denominator, so we can just add those together. Okay, so now it's time for you to try. I'm going to leave those problems in the window. Go ahead and try number 3. And when you come back, we'll do it together. I'll leave this in the window. All right, we're back. So first step is to get rid of the coefficient of x squared. And we're going to complete the square. Take this, divide by 2, and square it. If you do that, you get 25 over 16. And now we have a perfect square over here. And remember, this number is always the coefficient of x divided by 2. So that would be 5 over 4, if you did the arithmetic correctly on that. Multiply both sides of this by 8, and we get negative 40 over 16. And now we have a common denominator, so we can add those fractions. And 25 plus negative 40 is negative 15. Change that to power notation. And we have to get rid of that power. So we do the opposite of squaring, which is square rooting. Remember, put a plus or minus on the opposite side of the equation whenever you square root both sides of an equation. And we get plus or minus square root negative 15 over 4. Actually, we should keep that root 16. And remember, that negative inside the root comes out as an I. And square root 16 is just 4. So now we can put the 5/4 on the other side. And finally, x is equal to 5 plus or minus I root 15 all over 4. And that's the final answer. If you got that answer, good job. Okay, so why don't you try number 4? I'm going to leave all that stuff in the window. And when you come back, we'll do it together. All right, we're back. Let me just move that over. Again, you can put a divider on your paper if you need to, because this is a lot of work. It kind of sometimes bleeds into the other problem, and you don't want to get confused. So first step, as usual, get rid of the coefficient of x squared. And we're going to put the 3/4 on the other side. And now, of course, we're ready to complete the square. And so we take 3/4 and we divide it by 2 and then square it. And we get 9/64. This is now a perfect square. Always take this number, divide it by 2, and square it. So far, all the numbers that we've had here are negative. That was just a coincidence. But sometimes you're going to have a positive here, and then obviously your numbers will be positive. In fact, I think the last problem that we're going to do in this type, last one of these types of problems is we're going to have a positive there. Okay, so that's going to be 3/8 when you divide 3/4 by 2. And multiply both sides of this by 16. And we get 48. I know that was kind of a big number there to have to deal with, but sometimes you have to deal with those. And 9 minus 48, that's going to be -39. Change the power notation. And we're going to square root both sides to get rid of that 2 power. Don't forget your plus or minus. And now we have root 39 over root 64 is equal to x minus 3/8. And we can pull the I out, or the negative out in the root as an I. And root 64 is 8. Put the 3/8 on the other side. And then we can combine the fractions because we have a common denominator. And there you go. So if you got that answer, good job. Okay, so on to the next problems. These problems are pretty much the same thing, but there's some slight differences. We have a coefficient here on the x term that is -1. And so we didn't have any problems like that where you have that weird coefficient. Sometimes students get confused by this. You know, there's no coefficient there, but it's assumed to be -1. Also, when we divide by 6, we're actually going to have to reduce one of these fractions. That's never happened before. But other than that, it's pretty much the same type of problem. Getting rid of the coefficient of the x squared term. And again, that becomes 1/6, and we have 2/6. And 2/6 is the fraction that we're going to have to reduce. So that becomes 1/3. And you don't really have to show, you know, that step, but I'm just going really slow here to make sure that you've got all this. So now we're going to put that on the other side. And of course, now we're ready to complete the square. And to complete the square, just like normal, you take this number, divide by 2, and you get 1/12. Again, dividing by 2 is the same thing as multiplying by 1/2. So if you multiply this by 1/2, 1 times 1 is 1, and 6 times 2 is 12. So it becomes 1/12, then you square that, and you get 1/144. I know that's kind of a big number, but you can use a calculator if you really need to. Okay, so now that's a perfect square. And remember, this number is always the coefficient of x divided by 2. Now again, we just had another negative there. That was just a coincidence. Sometimes you have a positive. Multiply both sides. Now again, this is a big number here. We're going to have to multiply both sides by 48. Again, you can use your calculator if you're not sure about that. In fact, I might do that myself just to be sure. 48 times 3 is 144. You know, just double check on that. So now, negative 48 plus 1 is negative 47. Oh, whoops. Sorry about that. That should be 144. Sorry. Negative 47 over 144. Combine this to power notation as usual. And now we're ready to get rid of that power. Square root both sides. And x minus 1/12 is equal to plus or minus square root negative 47 over square root 144. And remember, that negative is just going to come out as an I. And again, you can use your calculator for root 144, but that's just going to be 12. Again, on your iPhone, the button would probably look like this, something like that. So you plug in the number first, 144, then you push this button. If you're using an Android phone, then you're going to have to put the symbol first, and then push the button in there. It'll have probably parentheses here. Okay, so now we're going to put that 1/12 on the other side. And finally, x is equal to 1 plus or minus I root 47 over 12. So that's just another example. We're practicing these problems as much as we can because, you know, this is a very important concept that we need to get down. So we're just going to do, you're going to do one more of these, and then we're going to go on to the quadratic formula. And the good news is quadratic formula is going to be a lot easier than these problems here. Completing the square is one of the most difficult things that you do in the entire math curriculum. I'll leave number 5 in the window, and be aware that this problem, we have an addition sign here. When you divide, you're going to get a positive here. In all the previous problems, we had to deal with a negative number here. So this time it's going to be positive. Just be aware of that. In all the previous problems, it was just a coincidence that they were all negative. So try number 6, and when you come back, we'll do it together. All right, we're back. Now, I guess I could write that step there just to be absolutely sure that you know what's going on. So again, what's different about this problem is you have to reduce that fraction. You actually don't have to reduce it, but it makes it a lot easier. So now, as usual, we're going to put the 3/8 on the other side. And now we're ready to complete the square. And let me put a divider here so that things don't get confused. And take this number, divide by 2, you get 1/4, and then square it and you get 1/16. That's what you're going to add to both sides. Whoops, forgot to write a plus sign there. Multiply both sides by this by 2, and you get 6/16. And then we're going to factor And remember, it's always this number divided by 2, so that's going to give us 1/4. In this problem, we had plus signs there. Again, it was just a coincidence. In all the other problems, we had minus signs. 1 minus 6 is -5. And then put that into power notation. And we're going to square root. Okay, and then we get, whenever you have a negative inside that root, you can just pull it out as an I. Again, it's not really necessary to explain much with that because the rules, you know, they sometimes work and they sometimes don't apply, the regular root rules with those negatives in the root. So now we're going to put the 1/4 on the other side. And of course we can combine because we have a common denominator. But let me make some room here. And finally, x is equal to -1 plus or minus I root 5 over 4. So if you got that answer, good job. Okay, on to the quadratic formula. So those problems that we did and the problems from the previous class and I think the previous 2 classes, we learned how to complete the square to solve quadratic equations. That method works for every quadratic equation. But there are some methods where there's an easier way to do it, and that's the factoring method. We also learned that. But now we're going to learn a formula that we can use where we just plug numbers in and get the answer immediately. And you might say, well, how come we didn't learn this at the very beginning? Well, you need to know the factoring method for multiple reasons. And you also need to know how to complete the square because that's how you actually derive this formula that we're going to come up with. And I mentioned in the previous classes that in the real world, you would either factor an expression or you would use the quadratic formula. You almost never complete the square because it's just too long and tedious. So we're going to start with a generic quadratic equation. And the reason this is called generic is because, you know, these constants are not specific numbers. They're just letters. So A, B, and C are constants. And we're going to solve this equation. Once we solve this generic equation, that's going to give us a formula that will solve any quadratic equation where we just plug the numbers in and compute, and we're going to get the answer pretty quickly. And like I mentioned, we're going to solve this by completing the square. That's the method that we use to derive the quadratic formula. So, but before I do this, I want you to know that what I'm about to do is going to look really scary. And I want you to understand that you don't have to know how to do what we're about to do. If I took 1,000 students that know how to use the quadratic formula, I would be shocked if one of them could, explain how to derive this formula. And the reason for that is not that they are not capable of doing it, it's just that you're not required to do it in school. So just be aware, as I'm doing this, you don't have to, know how to do this. And you're probably thinking, well, if you don't have to know how to do this, how come you're showing it? Well, this formula, usually I don't show the derivation of formulas because, again, you don't really have to know the derivation. And also students just usually fall asleep anyway. But when it comes to this particular equation, it's so important in the K-12 math curriculum that I need to show you how this formula is derived. But again, I'm going to constantly remind you that you don't have to know this. All right? So if you really don't care, you can just skip forward, 2 or 3 minutes and go to the actual problems. But in fact, I'll give you the problem number if you want to do that. It'd be problem 7, where we first start the quadratic formula. But in case you want to know where this formula comes from, we're going to go ahead and solve this generic equation with the completing the square method, and that's going to give us the formula that will solve any quadratic equation. So just like we would do in previous classes, or previous problems we just did, we're going to get rid of that a first, because we cannot complete the square unless we get rid of that coefficient of x squared. So now a divided by a, that just makes it go away. That's the whole point of that. And b over a, there's really nothing you can do with that but write it as a fraction, b over a. Same thing with c over a. We just leave that as c over a. You know, any fraction with 0 in the numerator and a regular number in the denominator, that's just going to be 0, just as we learned in the previous problems and the previous classes. So we got rid of that a, that coefficient of x squared, and now just as we did in the previous problems, we're going to get that term here without an x. We're going to put that on the other side. All right. And now we're ready to complete the square. Now this is where things can get a little intimidating for students. You're going to take this algebraic expression and you're going to divide it by 2 and square it. But this is all stuff that you learned in my pre-algebra course or my beginning algebra course. So you divide by 2, and when you do that, just as we did in the previous problems, you change it to multiplication and you flip it so it becomes 1/2. Again, you can write that 2 as 2 over 1 because it's a whole number. Any whole number can be written as 2 over 1. So then you multiply across, b times 1 is b, and a times 2 is 2a. So that's pretty simple. I'm going to label that as step number 1. Then you're going to take b over 2a and you're going to square it, just like we did in the previous problem. So we have b over 2a times b over 2a, and we get b squared over 4a squared. And again, if you don't know why 2a times 2a is 4a squared, then you can just go to my pre-algebra course or my beginning algebra course whenever we learn that. So that is the term that we're going to add to complete the square. And I know that that seems really complicated, but it's just basic algebra. That's all we're dealing with here. So I'm going to move this over, and I might find some place to put that. I don't know really where to put that at this point, but I'll find some place to put it later. But we're going to add b squared over 4a squared. Okay, so now we completed the square. It may not look like it, but we did complete the square. And remember, this number is always the coefficient of x divided by 2. So we already found that that's b over 2a. Now here, we're going to have to get a common denominator just like we did in the other problems. So we're going to have to multiply both sides of this fraction by something to get a 4a squared in the bottom. And we're just going to multiply by 4a because we already have an a here. So if you multiply this by 4a, we're going to get 4a squared. Again, that might seem a little intimidating. And I'm going to put this negative up in the numerator. In fact, I should probably just do that immediately, just in case you're confused by that. Again, you can put a negative next to the fraction line, or you can put it in the numerator. You can put it in the denominator. You can put it anywhere. So we're multiplying both sides of this by 4a, and we get 4a squared in the denominator here. So now we have a common denominator on this side, so we can add those fractions. So we're going to put this in power notation as usual. Again, I want to remind you, you don't have to know how to do this. I'm just doing this because this is one of the most important formulas in all of K-12 mathematics. And so it's worth it to just show you this. So now we have a common denominator, so we can add those together. And now we have to get rid of this square, this power notation. So obviously we're just going to square root both sides as usual. And remember, whenever you square root, you have to put a plus or minus on the side opposite the variable. And now we have x plus b over 2a. And as usual, remember, square root a over b is equal to square root a over square root b. That's one of the principles. Sorry, we're using the same variables, though. I don't mean to confuse you with that, but negative 4ac plus b squared over square root 4a squared. Okay, so we're getting close here. Now, it's important to understand that the square root of 4a squared, you're just going to square root the 4 and the a squared. So let me just rewrite the numerator. And by the way, we can flip this numerator around. I don't know if I should do that in this step or the next step. I'm just going to leave it for now. So if you square root this, the square root of 4 is 2, and the square root of a squared is just a. So we're just left with 2a. And I'm going to go ahead and move that up a little bit. Okay, so now at this point, all we have to do is get that b over 2a on the other side. And remember, whenever you run out of room, that's okay. You just have to write an arrow up here. So we now have x is equal to, and we put that b over 2a on the other side, it's going to become a negative b over 2a. Then we have plus or minus root, and I'm going to go ahead and flip those terms around. I'm going to write the b squared first, because that's just the way it's typically written. And at this point, we have a common denominator, so we're ready to go ahead and combine those. Again, we have 2a and 2a. It's a common denominator. So we can put those together, and our final formula is negative b plus or minus root b squared minus 4ac all over 2a. And that is the quadratic formula. So you're probably thinking, well, I didn't like that for one thing, and I don't understand why we should care about this. Well, this is a formula where you can solve, again, any quadratic equation. And what that means is if you start out with some quadratic equation up here, for example, you just plug in the a, b, and the c in here, and you immediately get your answers. Well, not immediately. You might have to do a little bit of work to simplify. But that's the power of this formula. Again, this is called the quadratic formula. Now, again, I want to say you don't have to know how to do this. You don't have to know how to derive this formula. All this stuff right here, you do not have to know. I want to be absolutely clear. You do not have to do this, okay? But you do need to memorize this formula. And I know what you're thinking. You're thinking, I can't memorize that formula. Well, it's actually going to be pretty easy to memorize. As we use it more and more and more, you're going to, it's going to get to the point where you couldn't forget it even if you wanted to. And I'm going to rewrite the formula for you multiple times so that you, can constantly see it. And it's just, again, you're going to memorize it pretty easily, as you'll see. So first of all, again, it says use the quadratic formula. So we're going to use the formula now. And I'm going to write the generic form of the equation to get you to understand what's going on here. So again, we labeled the coefficient of x squared as a, the coefficient of x as b, and the last number c, just like we did in the when we derived the formula. You see, we have a, b, and c. So as you can see, in this case, a is going to be 3, b is going to be 5, and c is going to be 1. All right? That's the numbers here. That's what they correspond to. So now I'm going to write that formula down, and I'm not going to write that every single time. I'll just pop it on the screen, so you don't have to watch me write it. So now all we're going to do is just plug in those numbers. So b is 5, and we have b again. B is squared there, and then minus 4 times a, and a is 3. If you watch up there, a is 3 and c is 1. So we're just going to plug in that 1 there. And then in the bottom we have 2 times a, so a again is 3, and there you go. So this is the answer. All we have to do now is just simplify it. So we're really going to simplify what's inside the root first. We can't really do much with anything else. We can simplify this. That obviously becomes 6. 2 times 3 is 6. 5 squared is 25. And multiply all this together and you get negative 12. Okay, so now we're just ready to write the final answer. 25 minus 12 is 13, so we have root 13, and we can't really do much with that expression at that point. So, as you can see, the quadratic formula is a very powerful tool because we just plug numbers in and we get our answer quickly rather than having to use the completing the square method. So let's try some more of these problems before you try one on your own. I'm going to label the constants and write the formula down. Okay, so now we're just going to plug in those numbers into the formula. Again, this is the formula we're plugging into. So we have negative b plus or minus b squared minus 4 times a times c. That's what the formula tells us to do. And then on the bottom, 2 times a. Again, a is negative 7. And all we have to do at this point is just simplify. 3 squared is 9. And multiply all that stuff together. You can use a calculator if you want to. But negative 4 times negative 7 is going to be 28. And 28 times 2 is 56. Again, we're just multiplying all this stuff. That's very important to understand. We're just multiplying all this stuff together. Negative 4 times negative 7 times 2. All right, so 2 times negative 7 is negative 14. And then inside the root, 9 plus 56 is 65. Now there's one more thing that we can do at this point. This might be a little confusing for students, but I'm going to show you anyway because you may see the answer in a textbook written with these numbers as positives. And the reason for that is if I multiply both sides of this fraction by negative 1, I'm going to change all the signs. So that's going to be 3 plus or minus root 65 over 14. But you might think to yourself, wait a second, how could you do that? Because you only change the signs of 2 of these numbers. Don't you have to change the signs of all the numbers? Well, this is a plus or minus, so if you multiply it by a negative 1, it just becomes it doesn't change. It's still a plus or minus. If this is plus and you multiply by a negative, then it changes to negative. But if it's a negative and you multiply it by a negative, it changes to a positive. But it's still either plus or minus, so it doesn't really do anything. So if you look at a textbook and you see this answer written like so, just understand that that's the reason for that. It's not a mistake. And when you multiply the top by negative 1, remember you're just using the distributive rule. You multiply this and then you multiply this by a negative. You can we can go over that more if you want me to, but that's not really that important of a point with this stuff. Okay, so let's try a couple more of these problems before you try one on your own. Again, I'm going to label the constants, and I'm going to write the formula. And again, the coefficient of x squared is 1, so that's why a is 1. The coefficient of x is negative 9, that's why b is negative 9. And this last number is c, that's 9. So now we just have to plug the numbers in. So b is negative 9, but now we have a double negative there. So be very careful. Sometimes you're going to have a double negative. It's negative b, right? The formula tells us it's negative b right here, but we already have a negative, so it's going to be a double negative. And then we have b squared. Now, a lot of students, what they like to do is, because b is negative, what they'll do is they'll write negative 9 squared like that. That is incorrect. Okay, that is not the correct expression. You need to put parentheses around the negative 9. And I know a lot of students, they don't want to do that. They say, well, I don't understand. Why do I have to do that? Well, because you're multiplying b times itself, all right, to get a positive 81. Negative 9 squared with parentheses means positive 81. That's what we want. But if you write negative 9 without parentheses, that equals actually negative 1. That's not correct. You're not using the right notation. Again, a lot of students would say, well, what's the big difference? It doesn't matter. Yes, it does matter. Okay, you have to use the language properly, or else you're going to make mistakes and people are not going to understand what you're writing. And again, a lot of students, if you write -1, then you would subtract this number, and you would get some big negative number like 81 plus 36. That would be 117, so you'll get -117. That's not the right answer. So you can even fool yourself by accidentally putting a negative there. Again, you're squaring the -9, which means you're multiplying 9 by itself. So that's going to be positive 81, not negative 81. So we're out of room, so we're going to have to go up here. And all we have to do at that point is just simplify that. Now that's a double negative, so it becomes positive 9, looking down here. And then, as I said, -9 squared, that's going to be 81. And then, again, we're multiplying all this. It's very important to understand you're multiplying all these numbers. -4 times 1 is -4. -4 times 9 is -36. And now we get 9 plus or minus, and 81 minus 36. You can do that in your calculator if you need to. And that gives us 45. So at this point, the problem is we have a perfect square factor inside that root. So we have to take that 45 and factor it to 9 times 5. And 9 times 5, remember, we're using this principle, square root a times b is equal to square root a times square root b. That just becomes root 9 times root 5, and then square root 9 is 3. Then you can just put it together to 3 root 5. But I'm not going to show that every time because it's just going to get too tedious and we don't really even have enough room. So I'm just going to write the final answer as 9 plus or minus 3 root 5 over 2. Again, you should be able to change the root 45 to 3 root 5. That's something that you should know how to do in your head at this point. And if you need to show the work off to the side like I did, that's fine, but I'm not going to show the work because that's just getting to the point where, you know, it's just going to be too tedious. These problems are too long at this point for us to stop at every step. Okay, so we're going to try one more of these problems before you try one on your own. So I'm going to label those constants, and I'm going to write the quadratic formula. Again, this number is always A, this number is always B, and this number is always C. So now we're just going to plug in. And again, we have a double negative, so be very careful with that. The double negative is going to become a positive. Now we have -2 squared minus 4 times A is 6, and C is -3. And on the bottom we have 2 times A, and A again is 6. So we're just plugging those numbers in. So now we just have to simplify, and then we'll be done. So this is a double negative, it becomes +2. And -2 squared, again, don't put -2 squared like this. That is equal to -4. That's not correct. It's got to be -2 squared with parentheses, so it's +4. Do not do this. Please do not do this. That's one of the primary mistakes that students make again and again and again. So we have 4 minus, and again, you can multiply all these together. Don't be afraid to use your calculator. -4 times 6 is -24, and -24 times -3 is 72. And it's going to be +72 because you have a negative times a positive times a negative. And 2 times 6 is 12. And then we get 76. 4 plus 72 is 76. And at this point, we need to pull out a perfect square out of the 76. Now that's going to be kind of a tall order. Again, you can use your calculator. I'm going to try dividing by 4, and I can see that that's going to work. So that's going to be 4 times 19. And I don't think I'm going to have time or the room to really show much of that. So 4 comes out as a 2, and the 19 stays in. And at this point, we're not quite done yet. And the reason we're not done is we can actually reduce that fraction. Whenever you have numbers in each term that have a common factor, you can divide all those numbers by that common factor. So 2 root 19 has a factor of 2, and this is obviously 2, that it's a factor of 2, and 12 has a factor of 2. So divide everything by 2. 2 divided by 2 is 1. 2 root 19 divided by 2, that just gets rid of that 2, because again, this is 2 times root 19. If you divide by 2, you just get rid of that multiplication, end up with root 19, and 12 divided by 2 is 6. So that's a case where you had to reduce that final answer. Okay, so finally it's time for you to try some of these problems. I'm going to leave these in the window. I want you to try number 11. And I want you to show the formula that you're using. I want you to constantly rewrite this. First write the, well, you don't really have to write, label the constants if you don't want to. You probably have the point by now. Just remember that this is going to be A, this is going to be B, and this is going to be C. If you can remember that, you don't have to write this stuff here, But I do want you to write this formula, because the more you write it, the more the quicker it's going to be for you to remember that formula. And also, you need to show that the tool that you're using. Later on in your math education, you can probably get by without having to write this formula every time you use it. But for now, I want you to keep showing the tool that you're using. So go ahead and try number 11, and when you come back, we'll do it together. All right, we're back. So I'm going to label the constants, and I'm going to write the formula. And we're just going to plug in numbers. So negative b plus or minus b squared minus 4 times a times c all over 2 times a. And now we just have to simplify. So we have 5 squared is 25, and then we're just going to multiply all this together. And it's kind of a coincidence that just ended up being the same product that we did before. So that's just going to be 72, positive 72. And we get negative 12 in the denominator. And 25 plus 72, that's going to be 97. So I guess we didn't really need such a big root symbol there. Over negative 12, and that is the answer. So we didn't really have to do any simplifying beyond just what was inside the root. Actually, you know what? If you got that answer, then you're absolutely correct. But remember, if you have 2 negatives here, then textbooks will oftentimes reduce it a little bit more. If you didn't do this, then that's okay. But you should probably simplify it a little bit more and just get rid of those negatives. Again, the reason that works is you multiply everything by a negative, but when you multiply a plus or minus, it just stays plus or minus. I know that's a little confusing to understand, but it's something that you need to do. So if you got that answer, good job. Okay, on to number 12. For number 12, the coefficient of x squared is negative 1. So just be aware of that. Don't be confused by that. Try number 12, and when you come back, we'll do it together. All right, we're back. So I'm going to label the constants as usual, and I'm going to write the formula. Be sure that you write this formula. You have to show the tool that you're using. And now we're just going to plug in numbers. So b is 3, so we have negative b plus or minus b squared minus 4 times a times c all over 2 times a. Again, a is negative 1. So we're out of room, so that's okay. We can just go up here. And we just have to simplify that. So we have -3 and we have 9. Multiply all those together and you get positive 28. So we have 9 plus 28 over -2. And 9 plus 28 is going to be 37. And there's nothing you can really do with 37, but these numbers, they're both negative. So you can go ahead and change those to positive. If you didn't do that, that's okay, but that's a good thing to do to kind of simplify the expression. You want to get rid of negatives if you can. So if you got that answer or this answer, good job. Okay, on to number 13. Now, because you don't have the formula written down, I'm going to go ahead and write the formula and label the constants. All right, so go ahead and try number 13, and when you come back, we'll do it together. All right, we're back. So we're just going to plug in the numbers as usual. B is 6. Plug in B again, and plug in A is -3, and C is -1. And all we have to do is simplify at that point, as usual. And -4 times -3 is 12, and 12 times -1 is -12. And then we get -6. And 36 minus 12, that's going to be 24. And we're going to have to change 24. 24 is 4 times 6. The 4 comes out as a 2. And you're left with 6 inside the root. Again, if you are not sure how we did that, just go to the previous classes on roots. That's all review information. Now there's two things that we can do. We're going to have to do both of these at the same time. We're going to reduce all these because 2 goes into all these numbers, so we're going to divide everything by 2, but if we divide everything by -2, we can get rid of those negative signs too. So we're going to have 3 plus or minus root 6 over 3. So don't panic if you didn't get to this point. If you didn't get to that point, that's okay. If you got these answers or something like this, that's okay, but you just continue down to this point and get your final answer. Remember, this coefficient here on the x is actually 1. So go ahead and try that problem. I've got the quadratic formula here for you, and when you're done, we'll do it together. All right, we're back. So I'm going to go ahead and label the constants, and I'm going to write the formula. Okay, and then we're just going to plug in numbers as usual. So B is 1. 1 squared minus 4 times A times C, which is -1. I'm going to move that over a little bit. And because we're running pretty close to the other problem, we're going to have to put dividers. Again, don't be afraid to put dividers. And on the bottom we have 2 times A, and A is 11. So now we just have to simplify that expression. One squared is 1, and -4 times 11 is -44, and -44 times -1 is +44. And 2 times 11 is 22. And so now we have -1 plus or minus root 45 over 22. And just like we did in the other problems, you can pull out a perfect square out of that root 45. That's 9 times 5. 9 is a perfect square. It comes out as a 3, and you're left with the 5 in the root. Now again, don't tell me that you don't know how to do that. I'm not showing every step, but you know how to do that. We did that in previous classes multiple times. I'm just not showing the steps because at this point, if we show the steps in this work, you can see it's just going to get really, really long. You need to be able to do some math in your head, especially at this point when we're taking intermediate algebra. So anyway, if you got that answer right, good job. Okay, so something different is going to happen in this problem. So let's do this one together. We're going to label the constants as usual, and I'm going to write the formula. Remember, you need to show the tool that you're using. So now we're going to plug in the numbers. B is -3, so that's going to be a double negative. And then remember, do not write this. This is wrong. Okay, you need to write parentheses. -4 times A times C all over 2 times A. And of course we're out of room here, so we're going to need to go up here. And just simplifying that expression, we have 9, and -4 times -2 is +8. 8 times 5 is 40. And then we have -4 in the bottom. And what's different about this problem is, notice that inside the root we actually have a perfect square, so that makes this a lot easier. 49 is a perfect square. So the final answer is just going to be 3 plus or minus square root 49 is just what number times itself is equal to 49. That's 7. And actually that's not the final answer. The final answer is going to be x can be 3 plus 7 over -4, which is going to be -10/4, which reduces to -5/2. Or x can be 3 minus 7 over -4, which is -4 over -4, which is 1. And those are the solutions. So that problem was different because we just ended up with rational solutions. Okay, so let's try one more of these. Something interesting is going to happen on this problem too. So let me write label the coefficients, and I'm going to write the formula as usual. All right, and what you're going to find is that there's only one solution to this quadratic equation because something special is going to happen. And we're going to simplify. And we get 64, and -4 times 1 is -4, -4 times 16 is -64. Now do you see what happens inside this root here? 64 minus 64 is just 0. Now it's very important to understand that well, obviously square root 0 is 0. So we have 8 plus or minus 0 over 2. Now, if you add 0, you don't do anything to -8. If you subtract 0, again, you don't do anything. So you just end up with -8 over 2, which you can just simplify to -4. So there's actually only one solution. Notice when you have 0 inside this root, the plus or minus, it doesn't do anything. It just goes away because subtracting 0 doesn't do anything. Adding 0 doesn't do anything. So you're not really, you could say that you have two solutions, but they're both -4 because you have -8 plus 0 over 2, which is -4, and you have -8 minus 0 over 2, which is also -4. So there's only one solution. Okay, so I want you to go ahead and try number 17. On number 17, we're going to have rational solutions, just like we did for number 15. So go ahead and try 17, and when you come back, we'll do it together. All right, we're back. So I'm going to label the constants, and I'm going to write the formula, the quadratic formula. All right, and we should probably put a divider here. And as usual, we're just going to plug in the numbers. And we have a double negative. And remember, this is such a common mistake for students to make. do not put -8 squared. That is not correct. It's one of the most common mistakes students make. You have to put parentheses. I want to move that over a little bit. Now, as usual, we just have to simplify. We get 64. -4 times 3 is -12. -12 times -3 is +36. And what's different about this problem is that just like in problem number 15, we're going to have a perfect square here. 64 plus 36 is just 100. 100 is a perfect square. So now we end up with 8 plus or minus 10 over 6. Again, square root of 100 is just 10. 10 times 10 is 100. And then we have 8 plus 10 over 6, which is going to be 3, it looks like. Or we have 8 minus 10 over 6, which is going to be -1/3. And those are the solutions. All right, so if you got those answers, good job. All right, so if you got that answer, good job. Now I want you to try number 18. For number 18, you're going to find there's only going to be one solution. Okay, because this situation is going to occur. So try number 18, and when you come back, we'll do it together. All right, we're back. So I'm going to label the constants, and I'm going to write the formula. And as usual, we're just going to plug in the constants. So we have -30 plus or minus root 30 squared. And I'm sorry I give you kind of a big number there. 4 times A times C. We got a lot of big numbers here. Sorry about that. And finally, x is equal to 30 squared is going to be 900. And if you multiply all these numbers, -4 times 9 is 36, and -36 times 25 is 900. And 2 times 9 is 18. So you can see that we have 900 minus 900, which means that what's inside the root is just going to be 0. And whenever that happens, you're going to end up with one solution. So we have plus or minus square root 0. So we have -30 plus the square root of 0, which is, plus or minus the square root of 0, which is 0. And -30 plus 0 would just be -30. And -30 minus 0 would just be -30. So you're going to get the same answer no matter what. And I might just demonstrate that here. So again, we have -30 plus 0 over 18, and we have -30 minus 0 over 18. So again, this is just going to give you the same answer. You're going to get -30 over 18. So you don't have to write both of those. So we're just going to write x equals -30 over 18. And then that reduces to, let's see, I think 6 goes into both those, so divide both by 6, and you get -5 over 3. And that is the final answer. Okay, so let's go on to the next problem. Now we're going to do some problems where the solutions are going to be complex. So let me do these problems, or let's do these together, and let me label the constants, and I'm going to write the formula. Okay, and once again we'll just plug in the numbers. -b plus or minus root b squared minus 4 times a times c, all over 2 times a. And now we just simplify, and what you're going to find is that inside the root we have a negative. 4 times 5 is 20, 20 times 3 is 60. 2 times 5 is 10. And 49 minus 60 is negative 11. And when we have a negative inside that root, that means we have complex solutions. And remember, a negative can just come out as an I. And that's as far as we can go. That's the simplified solution. I'm just going to move these down a little bit. So we'll rectangle that. And again, that's just an example where you have complex solutions. Now, I want you to be aware that it's kind of confusing because really technically all solutions are complex solutions. But because this answer has an I, we call it a complex solution, while the other solutions, we call them real solutions where they don't have an I, which doesn't really make sense based on the definition of complex solutions, but that's just kind of a flaw in the logic when it comes to the math curriculum. You might want to call these imaginary solutions, but the problem is, technically they are complex. So it is confusing. You might say they have imaginary parts, but we're just going to call them complex solutions, even though that doesn't really make a whole lot of sense, because again, all solutions are technically complex. All right, let's do another one of these problems. So I'm going to label the constants, and I'm going to write the formula as usual. And then we're just going to plug in. So negative b plus or minus b squared minus 4a c. I'm going to move that over a little bit. All over 2 times a. 2 squared is 4, and then negative 4 times negative 3 is 12, and 12 times negative 2 is negative 24. So again, you can see that we're going to have a negative inside the root. Whenever you have a negative inside the root, you're going to have what they call complex solutions. Now, this is a situation where not only do we have a complex solution, but we also have a perfect square inside the root. So I'm going to, just to remind you, I'm going to factor to find the perfect square, but also to find the negative 1 that's going to come out as an I. And so the negative 1 comes out as an I, and the 4 comes out as a 2. So usually we can just write the 2 in front of the I, and then the 5 stays in because the 5 is not a perfect, it's not a perfect square. Okay, and then we can reduce. So finally we have x is equal to, divide everything by 2 and we get negative 1 plus or minus I root 5 all over negative 3. And we can also get rid of those negatives if we multiply both sides by negative 1. And that is the answer. So let's try one more of these before you try one on your own. Okay, I'm going to label the constants as usual. Whoops, I forgot to write equals 0. Then I'm going to write the formula. Remember, you have to show the tool that you're using. And we have negative b plus or minus root negative b squared minus 4 times a times c all over 2 times a. Okay, and again, we're just going to simplify. And we get positive 6 plus or minus 36. Negative 4 times 1 is negative 4. Negative 4 times 18 is negative 72. 2 times 1 is 2. And now 36 minus 72 is negative 36, and that's actually, 36 is a perfect square. The negative comes out as an I, as usual. So we have 6 plus or minus 6i over 2. And of course that just reduces to 3 plus or minus 3i. And there you go. So now it's time for you to try. Go ahead and try number 22. You're going to get complex solutions. And when you come back, we'll do it together. All right, we're back. I'm going to label the constants, and I'm going to write the formula. And we're just going to plug in as usual. So we have negative b plus or minus root b squared minus 4 times a times c all over 2 times a. And now we just have to simplify. Remember, follow order of operations, do the exponents first. Negative 4 times negative 3 is positive 12. Positive 12 times negative 6 is negative 72. 2 times negative 3 is negative 6. And then 49 minus 72, that's negative 23. And the I comes out, or excuse me, the negative 1 comes out as an I. And we end up with I root 23 over negative 6. And there you go. Actually, we can get rid of those negatives too. If you got the answer with the negatives, that's okay, but it's probably best if you get rid of those just because it makes the answer a lot simpler. Alright, if you got that answer, good job. Now go ahead and try number 23. I'll leave these in the window. And with 23, be aware that you're going to have to pull out a perfect square as well as the negative in the root. So the negative comes out as an I, and the perfect square is going to come out as some number. So try number 23, and when you come back, we'll do it together. All right, we're back. I'm going to put a divider, and I'm going to label constants. And I'm going to write the formula as usual. You need to show the tool that you're using. And now we're just going to plug in. All right, negative b plus or minus, and this is where you have to be careful. Remember, it's not negative b, it's not negative 1 squared like that. You have to put parentheses, or else it's not going to be technically written in the correct way. So a double negative becomes a positive. Negative 1 squared is 1. Negative 4 times 7 is negative 28. Negative 28 times 1 is negative 28. 2 times 7 is 14. Then we get negative 27 inside the root. And as you can imagine, 27 has a perfect square. We can factor it to 3 times 9. And the negative 1 also comes out as an I, so 9 times 3, the 9 comes out as a 3, the negative 1 comes out as an I, and the other 3 just stays inside. So if you got that answer, good job. Let me bring that down a little bit. Okay, so we have one more of these problems. And then we'll go on to the discriminant. So go ahead and try number 24. And when you come back, we'll do it together. All right, we're back. So I'm going to label constants. And I'm going to write the formula as usual. And we're just going to plug in numbers. And now we just have to simplify. And you can see that we're going to have a negative inside the root. And we get negative 4. Now 4 is a perfect square, so that's going to become 2. And the negative is going to come out as an I, so you're going to be left with 2I. And, you know, when you're dividing a polynomial by a monomial, you just divide each term. So 2 divided by 2 is 1, and 2I divided by 2 is I. So if you got that answer, good job. All right, we have one more thing to learn today, the discriminant. Notice that I've written the quadratic formula up here, but I've taken the part under the root and I've rewritten it down here. That part under the root is called the discriminant. Now the verb form of that word is discriminate, and you've probably heard that word. The general meaning is to tell the difference between things, or to differentiate between things. But it also has a negative meaning, meaning to prejudge. But in this class, the word, we're using the noun form of the word, and it just means to, again, tell the difference between things. And if you look at the previous problems, if you look under the root, notice that when we had a positive number under the root, 13 or 65 or 5, whenever we had a positive number under the root, we always had two solutions, two real solutions. But when we had a 0 under the root, in these cases, we had only one solution, because the plus or minus, for all intents and purposes, the plus and minus just disappeared. But when we had negatives under the roots, which are the problems that we just did, then we had two complex solutions. So we had a negative 11 here, a negative 20 here, a negative 23 there. We had complex solutions because we had imaginary parts. So that's why this expression under the root is called the discriminant. It tells the difference between the three situations. Now, there are two reasons that this expression under the root gives us information. One reason is it's under the root. And the second reason is it's to the right of the plus or minus sign. That's the sign of this expression, or this root expression. So because it's under the root, if we have a positive number under the root, then the plus or minus sign doesn't go away, and we have two solutions. And if we have a negative under the root, the plus or minus sign still doesn't go away, and we have two complex solutions. But if the expression is 0, then the plus or minus sign does go away, and we have one solution. So that's why, again, the expression under the root is called the discriminant, because it helps us to differentiate between the possible options. So you can take a screenshot of this information if you need to. All that information there tells us what exactly we're using the discriminant for. So it says here, find the discriminant of each of the following quadratic equations and use it to determine the number and type of solutions. Write one real solution, two real solutions, or two complex solutions. So those are the possible answers that we're looking for. So we're first going to find the discriminant, as it tells us to do, And let's write the formula. So b is 5, and a is 3, and c is -2. And maybe I should write label the coefficients first. So a is 3, b is 5, c is -2, and plug those in, and we get 25. -4 times 3 is -12. -12 times -2 is +24. And you can see that the discriminant is positive. So we can then conclude, without even doing anything else, without using the quadratic formula or trying to solve, we can conclude that there are two real solutions. So again, the discriminant tells us the type of solutions. They're real solutions, and it tells us the number of solutions. There are two real solutions because the discriminant was positive. You're going to see these types of problems in the math curriculum. So again, we're going to label the constants. Then we're going to write that write what the discriminant is, and then we're going to find the discriminant by plugging in the numbers. So we have -1 squared minus 4 times a times c. And remember, it's not -1 squared without parentheses. You need those parentheses. And d is going to be equal to 1 minus 4 times 2 is -8. -8 times 1 is -8. And you can see we have -7. So our answer was negative, and therefore we have two complex solutions. There's going to be two complex solutions to this quadratic, and I'm just going to bring that down there. So we say there are two complex solutions. And you know what I forgot? I think I forgot to rectangle the discriminant, because that's part of the solution. All right. So now let's do one more of these together before you try one on your own. So I'm going to label constants, and I'm going to write that formula for the discriminant. And then we're just going to plug in. So b squared minus 4 times a times c, and we get -16, and 16 minus 16 is 0, and if the discriminant is 0, that means we have one real solution. So again, we found the discriminant, and we figured out the type of solutions. They're real, and we figured out the number of solutions. There's only one solution. So I'm going to leave this page here in the window, and I want you to try number 28. Find the discriminant and figure out if there's one solution, two solutions, or two complex solutions. All right, so do 28, and when you come back, we'll attempt it together. All right, we're back. So I'm going to label constants, and I'm going to write the formula for the discriminant, and then we're going to plug in numbers. And so the discriminant is equal to 4. That's going to be 60, and 4 minus 60, that's going to be -56. And you can see, because the discriminant is negative, there's going to be two complex solutions. Again, the discriminant tells us how many solutions and the type of solutions. In this case, there are two solutions, and they're complex solutions. again, I know it's kind of confusing to call them complex because technically all answers are complex. Okay, go ahead and try number 29. If you got 28 right, good job. And when you come back, we'll do it together. All right, we're back. So I'm going to label constants, and I'm going to write the formula for the discriminant. Now we're just going to find the discriminant. And d is equal to 9. That's positive, so that means we have 2 real solutions. So if you got that answer, good job. Okay, go ahead and try number 30. It's the last problem for today, and when you come back, we'll do it together. All right, we're back. So I'm going to label constants, and I'm going to write the formula. And then we need to go up here, and the discriminant is equal to 12 squared minus 4 times a times c. And 12 squared is 144, and negative 4 times 9 is negative 36, and negative 36 times 4 is 144. So you can see the discriminant is 0, and in that case we have one real solution. So you found the discriminant, and we can say that we know the type of solutions, they're real, and we know how many solutions, there's only one. So if you got that answer, good job. All right, that was the class today. If you want to take screenshots of the work that we did to help you with your homework or to study for tests, you can go ahead and do that now. Here's screenshot number 1. And if you want to get this work, go ahead and take a screenshot of that. That'll help you with screenshot number 1. And here's screenshot number 2. Or 3 if you took that other screenshot. And also you can get this work. This shows how to complete the square on the generic form of a quadratic equation. And next screenshot. And next screenshot. And next screenshot. And the last screenshot. But don't go before you get your homework. Let's take a look at the homework. Here's the first screenshot of the homework. And the second screenshot. And before you go, I just want to give you some guidelines on how to do your homework. So when you're doing problems, namely these problems here, where they require you to use the quadratic formula to solve a quadratic equation, what I want you to do for every problem is to first write down the quadratic formula. And there's 2 reasons for that. One reason is it's going to help you to remember if you keep rewriting it over and over and over again. And the second reason is you're showing the tool that you're using. It's important to show the tool that you're using when you use some sort of a formula. And as far as showing your work, this is the first step, showing the tool. But the second step, I want you to plug everything in without doing any kind of simplifying. All you're going to do on the second step is just plug in. Okay, again, no work here, just plugging in the numbers. And then the final answer, that's up to you in terms of how fast you can get to the final answer. You can show intermediate steps if you need to. I would suggest probably showing at least 1 intermediate step, but you can show 2 or 3 intermediate steps if you need to. But all I require is that you show the tool that you're using, this formula, for every problem where you use the quadratic formula, and then you need to plug in and show the numbers plugged in, and then go to your, the steps you need to take to your final answer. Also, remember your homework has to have those 4 characteristics. It has to be complete, correct, neat, and in correct chronological order in your binder. And remember, if you don't do the homework, it's a 100% guarantee you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.